built. We'll talk about the power in the next slide, but there are these rails that you see that are 3U tall. It's the same height as a 3U server, and that the modules will mount onto these rails. Then they mount via M3 screws, or there's M3 threaded holes spaced every 0.2 inches on the rails that the modules will mount to. And 0.2 inches is 1 HP, so HP is a measurement of the width of a module. There's no real limits or specifications on how deep a module can be. Some modules are said to be skiff-friendly, which means they're very thin, so they can fit into very thin cases. But there's just no real common agreed-upon definition of what that means. It's usually about 4 centimeters. And with the depth, thinner modules usually mean wider modules because you can have the front plate and then the PCB parallel. If you have very thin modules, you'll have to put the PCB perpendicular to the front panel, which makes them deeper. So it just depends on what you can fit into your case and what your priorities are, I guess. Okay, let's talk about the power supplies. Each module in the back is connected to the power supply in the case via 10 or 16 pin ribbon cables. For the 10 pin, you have minus 12 volts, a bunch of ground pins, and then plus 12 volts. And then for 16 pin, you have all of that plus 5 volts and gate and CV. We'll talk about gate and CV in a little bit, but that pretty much is built-in patch cables behind the modules that not very many modules use them, but a few do. Yeah, and the important part, or one of the important parts, is that on the cable there's a stripe, and that goes to the minus 12 volts. Sometimes the power connectors are keyed, so they can only go in one way, but a lot of them aren't. And if you plug the power in backwards, you'll probably blow up your module, which is I'm always paranoid about, so I just check it 1,000,000 times. So for patch cables that actually carry the signals between different modules, they are 3.5 millimeter mono cables. There's 2 or 3 modules that do use stereo cables, but they're very, very rare. If you do need stereo, they'll be you'll use 2 separate mono patching cables. And then a few modules will use the MIDI TRS ports, which are a 3.5 millimeter stereo cable, which lets you use MIDI, which is a digital communication protocol for musical hardware. And that's pretty much just so that on your module you can use just the 3.5 millimeter jack instead of the huge MIDI port. Okay, we're going to talk about signals, the signals that actually go through these patch cables. There's 3 main types: audio, CV, and timing. So audio signals are meant to be heard. They will eventually be put out through speakers, usually chained through many, many modules, but eventually they'll get out to the speakers. They're relatively high frequency. Human hearing goes up to about 20 kilohertz. And I know that's not high frequency in electronics and RF and processors and everything, but it is high frequency for as far as signals that get sent over your patch cables. So the highest frequency will be your audio signals. And these are a maximum, they're bipolar signals, 10 volt peak to peak, so plus 5 volts to minus 5 volts at the maximum. Usually it's a bit lower than that, but that's for audio. Sorry. For control voltage is kind of a class of signals that controls a given parameter. Usually on a module, you'll have a potentiometer, usually like a knob or a slider or something. And then next to that, you'll have a patch point where you can plug in a patch cable to then kind of take over control of that knob using control voltage. And it's an analog signal too. All of the signals that go over your patch cables are analog. Control voltage also contains a standard called volt per octave, and this is for like tuning your oscillators to musical pitches. So if you're like, oh, I want a middle C, you'll send it, I don't know off the top of my head, but a specific voltage. And the nice thing about this is that it's just analog. Like even if the sound you're generating you're generating it digitally, the control is still analog. So it's very easy to use non-Western tuning systems or scale systems because it's just an analog signal. There's no like lookup tables that say this middle C is this frequency. It's just, it's analog. CV can be bipolar with 5 volt peak to peak, so plus 2.5 to minus 2.5, or unipolar, 0 volts to 8 volts. This is one of the most frustrating things and why it's like a format, not a standard, because these will both be existing in your system, and unless you like have memorized the outputs of every single port in your system, which there can be like hundreds, you'll sometimes like try and patch something that's expecting the bipolar 5 volt peak to peak with something unipolar, and it's like way too aggressive, or the other way around, and it's the change you're expecting isn't as much, which can be frustrating, but that is how it is. And the next kind of category of signals, I'll deal with timing, and there's 3 main types of these they'll go over, but these are 0 volt to 5 volt pulses, and these deal with time. So a trigger is just a brief pulse, so it goes 0 volts to 5 volts, back to 0 volts immediately. And if you send a trigger to a module, you're pretty much telling it to, like, whatever thing you do it now. Gate is similar, but a little different in that it's open or closed like any other gate. And you can have sustains. So, like if you're playing a keyboard into a Eurorack system, you can use gate so that when you press a key and then hold it down, the note will keep playing until you release it. And if you send gate to something, it's like saying, do the thing and keep doing the thing until I tell you to stop doing the thing. And then the third type of timing signals is clock signals. This is like musical clock, so it's probably better said as like metronome or something, but everyone just says clock. And these keep the modules synchronized rhythmically in a musical context. So they use the unit of pulses per quarter note. So each beat in your music, the clock will trigger evenly so many times. The most common value is that is 24 pulses per quarter note, because MIDI uses that. But with more pulses per quarter note, you get more accurate timing. So depending on your modules, you can set higher or lower resolutions. And sending a clock is like saying to follow my rhythm, follow my timing. So now that we have some theory about the technical aspects, let's talk about some common module types, like the types of modules you'll put into your system. And this is a very like high level overview. You can have many subtypes, many different ways of doing the same things. But this is kind of like the broadest categories of modules. So first, I don't know if you can read this, but is an oscillator, and an oscillator will generate a pitch at an audio rate. This is usually the kind of starting point for the signal chain that will eventually get put out through the speakers. These can be analog or digital, but the output is always analog. And then you'll have a bunch of different waves. The kind of standard analog waves are sine, square, saw, triangle, ramp, and ramp waves. On the digital side of things, you could have like wavetable oscillators, or just like really weird oscillators that do much more complex waves. But those are kind of the core analog waves. And most oscillators for inputs, will have a volt per octave, so you can tune it. A way to select which wave it is generating, and then pulse width for your square waves, or your pulse width waves, I guess. And then the output will be the mix out, like audio out, a mix of all of the waves, or sometimes they'll have individual outputs for each wave. And usually you would put the output of that into a filter, which will only let certain frequencies through. The three main types are low pass, which only let low frequencies through, high pass, which lets high frequencies through, and band pass, which lets like just a certain range through. And then there will be resonance, which kind of adds a little bit of feedback and emphasizes right at where the cutoff is. And the cutoff of like what frequencies you let through and which ones you cut out, it will add emphasis there. And some can self-oscillate, meaning they'll like generate their own tones just through the feedback, which can result in a very like screamy, aggressive sound, which I really love. The inputs commonly will be the audio input of what is going to be filtered, the filter cutoff, or where that point is at which you let frequencies through or cut them off, and then how much resonance you want, how much like emphasis you want at that cutoff, and then a way to determine which filter type you use. And then the outputs are just the filtered audio. Next is a VCA, or voltage controlled amplifier. These are pretty simple. They just take a signal in and amplify it, or de-amplify it based on CV or based on a control. There's a kind of mantra in the Eurorack world that you can never have too many VCAs, in part due to the multiple classes of control voltage, actual voltage ranges, is a big reason for this, because if you have one of the bipolar CV outputs, you can put it through a VCA and then kind of amplify it up to be acceptable by the unipolar inputs. Yeah. And so the inputs are the signal that you want amplified or decreased, and then CV or control voltage, or maybe a knob or slider or something that will determine how much that signal is changed, like amplified or decreased. And then the outputs are just the amplified signal. Envelopes are a way to control a given parameter or a given patch point, I guess, over time for a specific note. There's generally 4 stages, or some combination of 4 stages, called attack, decay, sustained, release. Attack is like from the trigger, how fast it goes from the minimum to the maximum of whatever this parameter that you're controlling is. So attack goes how long it takes to go from minimum to maximum. Decay is where how long it will take to roll off a little bit. This is so that you can have really like plucky, almost like string or guitar-like sounds. And then sustain is like how is the volume that you want it to sustain at. So if you're playing a longer note, it will just like stay in the sustain because it's sustaining the note. And then release is how long it takes to get back to 0 once the gate is released. And then inputs are the trigger or gate to actually trigger the envelope to start this change, and then controls to change the different stages that I just talked about. And the common outputs are CV out or control voltage out. These envelopes generally don't directly affect a signal themselves. They're just meant to affect a different signal or a different parameter, like a filter or a VCA. And then LFOs are low frequency oscillators. Usually like very low frequency because they're sub audio, often like sub hertz. And they're kind of like a regular audio oscillator where they have sine, square, saw, triangle, ramp waves, or other weird waves. Those are the common ones. And those are used to modulate a parameter over time, regardless of the note that's playing. So this is more of like a long-running modulation source. And inputs or controls will be how fast it's oscillating, and then a trigger to like start it over at a specific point. And then outputs again is just CV. You then have sequencers, which are they just generate, or you can write musical patterns with them to then control other modules. Some are just for drums and that like just have gates or just have triggers. If you want melody, you'll need gates and volts per octave for when to start and stop a note, and then the pitch of that note. And many have CV for like for velocity or modulation for that note. You can also have samplers, which will play audio samples, either like loops of like drum breaks or something, or one shots are just one drum or whatever audio you want. And you can also do granular synthesis with some samplers. Granular synthesis we'll talk about it in a little bit, but it's pretty much taking very, very small samples and playing them very, very fast to generate tones. And you can also have full voices, which are the full synth voice in one big module. They kind of break the modular philosophy because they have all of the components together. They have oscillators and filters and envelopes and LFOs and utilities and everything all in one. But these are a great way to get into it. And yeah, I'll talk about that in a bit. There's also utilities like mixers, things to split signals, stuff like that. Also logic. There are modules that are like actual like logic gates that you can use to control your music. They have there are 1U tiles, which are most modules are 3U, but there's recently there's been some manufacturers that make 1U tiles that are thinner, take up less space, but are mostly just for these kind of utilities things, which is nice. And then the last common module type is effects. You can have the standard effects like reverb or distortion or delay, but there's also really, really, really weird stuff, which is where one of the places that Eurorack really shines in my eyes is the just like really bizarre things, bizarre effects. Like there's one of the modules I have is I don't even know how to describe it. They describe it as a texture synthesizer. And so it takes in some audio and has a digital buffer of a couple seconds of audio that you last played into it. And it will randomly, or you can select it, but usually it's randomly. It will play a very short sample from that audio buffer, which can generate weird tones and weird effects that are distinct from the audio that's being played in, but kind of harmonically related, which is pretty cool. But like, it's weird, and I can't really wrap my head around it, but it's amazing. Yeah, just a second. So now that we have some understanding of the common modules that you would put into your system, there are different approaches to patching or interacting with your system that we're going to talk about. First is East Coast synthesis. And this was first made by Dr. Bob Moog. This is often called subtractive synthesis. It's kind of what we described before, where you take a harmonically rich wave and filtering it. So you take like square wave or a saw wave, put it through a filter and envelopes. This is kind of the most dominant architecture, I guess, of synthesis, because it filters behaves similarly to our mouths. Like, our mouths are filters, and so you can get very like expressive tones and stuff with this that is pleasing to the ear, because our ears are most optimized at picking up other people's voices. There's also West Coast synthesis, which is made by Don Buchla. This is also called additive synthesis, and it's kind of the opposite, where you take a very simple wave, like a sine wave, and then you modulate that sine wave really fast to add harmonics to it. This is much less intuitive. The sounds you get are still amazing, especially you can get really great like bell and string sounds with it, but it's at least I find it to be less intuitive. And it was also made by Don Blucla in the late 60s, early 70s, when he was doing a lot of acid. And yeah, and the people who were kind of in that West Coast synthesis scene would buy a synth from Buchla, because it was the Buchla Synth Company. And they would actually rumor is they would actually paint LSD on the front panels of their synths and just like lick it, or put it put a little bit on their finger and lick it, so they are able to trip while doing stuff. I don't know if that's actually true, but that is a common story. Another way to approach is similar to the musique concrète. Sorry for the pronunciation. Concept, which was a genre of music starting in France in the 30s, I believe, where they would pretty much take a tape recorder out into the world, record things on their tape recorder, and then come back and do tape manipulation on it with cutting the tape, rearranging it, adding effects and stuff. And this approach is still very alive in the Eurorack world, which I like a lot, because there are tape loopers and sampler modules that you can do this same kind of thing with. They're often digital, like they are sampling the incoming audio and putting it into RAM, but there are actual modules that have actual magnetic tape being dragged over read and write heads, which is pretty cool. We talked a little bit about granular synthesis, which is kind of a similar thing, where you take a sample and then take a very short sample, like less than 1/10 of a second, and play 50 of them all at a time and triggering new ones once at at audio ranges, so you can get weird, indescribable tones, which is kind of the related thing that I like a lot. And then you can also, another approach is to just use Eurorack as an effects module for other instruments, which can be great. One of the downsides, though, is that you have to convert to and from Eurorack voltages, because the Eurorack voltages are very loud compared to other audio technologies, I guess, especially guitar pedals. Like, guitar pedals are expecting, like, even active pickup guitar will only output like a couple millivolts, maybe up to a volt at like the loudest. And so if you push a 10 volt Eurorack signal into that, it's not going to sound good and it might break something. So you have to like have dedicated modules that like bring the signal down. But it's definitely a way to approach it, and many people are doing that. Another kind of approach is to use alligator clips and clip them onto mushrooms and plants that are like alive, and then use because they're like capacitance, I think, change depending on stimulus, and then use those impulses as CV to control a Eurorack system. And it sounds kind of weird, but I highly encourage you to just go look it up at some point, because it's really amazing, especially the mushrooms. Like, just like touching the top of a mushroom will like, it totally reacts to it, and it's awesome. And there's also generative synthesis, which is where you pretty much set up your modules, set up your patch, start it going, and then back away and just let it do its thing. And it will generate its own music and modulate itself. And one of the ways you can do this is have LFOs modulate other LFOs. So like if you have an oscillator that's just droning, just a continuous signal, and you have one LFO that is modulating the pitch of that up and down, and then you have a second LFO that is modulating how much of the first LFO is getting applied to the oscillator. If those two LFOs are out of sync with each other, or like oscillating at different rates, the resulting modulation on the oscillator will be not really repeating, or it will only repeat after a very, very, very long time. So you can have like very long running performances with these that don't repeat. Okay, we're going to talk about Euclidean rhythms. This isn't strictly a Eurorack thing, but it's mostly talked about in Eurorack circles, and it's too interesting, I think, to leave out. So Euclidean rhythms are a way to generate musical rhythms using Euclid's greatest common divisor algorithm. So if you pretty much build a function that takes one number, which is the length of steps that you want in your sequence, and then a smaller number that is how many steps you want, or how many steps you want to be on. It's like how many drum hits you want in your pattern, and then use the greatest common divisor algorithm to kind of insert these steps as evenly as possible. There's some great videos on YouTube, and especially this demo that will explain it better than I can. But the result of this is a very, very interesting and engaging rhythm, and you can use this to play your hi-hats or whatever. But the most mind-blowing thing to me is that in 2004, it was discovered that cultures from all over the world have rhythms in their musical canon that are also Euclidean rhythms with offsets. And it's like pretty much, well, not all cultures in the world have these, but many of them do. Even if they're not, like, haven't contacted each other at the time that rhythm was made. So something about Euclidean rhythms are engaging to human brains, I guess, which is pretty cool to think about. And using a Euclidean rhythm module, you can generate new rhythms, which will also sound good. And so we are hackers. So what is the hackability of all this? If you just want a patch, like you don't want to do any coding or any soldering, you can still do a lot of things, a lot of hacking just with the patch itself. So you put your modules in, and one of the, like everyone knows, one of the classic ways to hack is to use something in a way that it's not meant to or intended to. And even though the voltage ranges for the different signals are different, for the most part, you're not going to hurt anything by patching anything to anything else in a Eurorack system. So one of the most classic things is to use audio instead of CV, or audio as CV, so that instead of this kind of very gradual effect or gradual evolution of whatever parameter, you're like going at audio rates. And an example of this is where you take the output of your synth, or a copy of the output of the synth, to modulate the filter cutoff. So it will be the point at which the filter is rejecting some frequencies and letting through other frequencies is changing with the same audio that's going through the filter, which is hard to describe, but it results in a kind of distortion sound that is very, it's directly harmonically related to the sounds going through it. So it sounds really like a really clean distortion, if that makes sense. Like it doesn't really get muddy. And this is a very common hack. So common, in fact, that the desktop synth maker called Arturia like includes this in their non-modular synths. Like there's a knob that will just like let you do this this hack, I guess. And then also you can consider other approaches that are to do the same thing with the modules that you have. An example of this is with sidechain compression. Sidechain compression is where it's usually used in dance music, where like when the kick drum happens, you bring down the volume on anything else, usually like the chords or something. You just bring the volume down really quickly and then bring it back up. And this results in a kind of auditory illusion that both the kick and the chords are louder than they actually are, because you can hear the kick more distinctly and you can hear the chords more distinctly. And it also gives a kind of pumping feeling that is very, very like traditional in certain genres of electronic music. And usually this effect is made with a compressor, which is it's a kind of complicated system, but with or circuit. But with Eurorack, you can get the exact same effect using a VCA, the amplifier, and an envelope, and you just invert the envelope so it's bringing the volume of the VCA down. at the same time that the kick is happening. So you can use this and not have to have a dedicated sidechain compression module in your case. Another hack that I like using a lot is using one source to modulate multiple parameters, like one LFO or one envelope or something like that to affect multiple parameters. There are patch cables that like have the part that goes in the port, but then they also have another port on top, so you can like stack multiple cables on top of each other to get copies of signals. You can use that, or modules that are pretty much just a bus that just connects them, so you can get copies of signals. That works well for VCA, or for control voltage, but it doesn't work as well for audio. There can be some weird distortion and stuff. But anyways, using one source to modulate multiple parameters, even in different voices, like one LFO modulating something in your lead synth voice and your bass voice, will kind of help them sound more in unison, more together, because they're evolving in a similar and related way. And another hack is that if you want a random wave, you can use your skin to do this. Like every single bleep bloop sound effect from sci-fi movies that is like computer thinking sound effect, like pretty much all of them were made with some audio tech holding a cable in their hand in order to get a random voltage or a random signal to then modulate the pitch. So we're all pretty technical. So what if we want to get a bit more deep and want to write some code? Many modules will have alternative firmware. There are many open source modules where people can contribute their own firmware and stuff. There's also this module on the left, which is the Euro Shield, which is, I don't know if you can see it, but there's just a teensy microcontroller and some potentiometers and some inputs and outputs, and you just write whatever you want in C++ or whatever, put it on the teensy, and it'll go. And then on the right is the Daisy Patch module, which is the same sort of thing, but that has a more specialized microcontroller that is optimized for digital signal processing, so you can write like digital reverbs and stuff using MaxMSP or Pure Data, I believe. And of course, you can just write regular software on your laptop that speaks MIDI, and if you have a MIDI to CV converter module, which is super common, then you can control your rack system with whatever software you write. There's also the Winterbloom's Soul module, which has a microcontroller in it, and it just runs CircuitPython, and it's really great. And it will read MIDI in. It has a good library for parsing that. And then you have gate and CV outs. And I just had to put this in because I was one of the beta testers for this module, so I can like personally say this is a great module. I love it a lot. So if you're good with soldering or not good with soldering but want to get good at soldering, many manufacturers offer their modules in kits, and oftentimes they are quite a bit cheaper than the assembled versions. Bafako and Thonk are two brands that are like primarily kit makers. Like you can get their stuff assembled, but that's really not what they do. And Thonk also sells components like the input jacks and knobs and buttons and stuff, and the ribbon controller or ribbon cables and stuff for you to make your own modules. And many times the kits will be in different complexities. I don't know if you can see on the picture, but this is a picture of a Bafako hex mixer module. It's a really great mixer. It's a kit, but it has a bunch of surface mount components that are pre-soldered for you. So you can just do your regular through-hole soldering, which greatly reduces the barrier to entry. But if you're good at surface mount, they'll usually offer it without the surface mount already assembled for a bit cheaper. Or if you have a library of components, you can just buy just the PCB and just the faceplate and do it from scratch, or source your own components. And then this is where I can't really comment too much because I'm not really an electrical hacker, but you can definitely design your own modules. There's the benefits is that the spec is kind of standard in that if your module speaks the same types of signals, it will work with any other module, and so you can integrate really well. There's also a very vibrant community for module design specifically. Like, I'm in the Winterbloom Discord server, and there's people talking about designing their own modules all the time and giving each other advice and stuff, which is great. It's also a cottage industry, so if you want to design a module and make it as your side hustle or whatever, you can definitely do that. There are thousands and thousands of different manufacturers, most of whom are just one person at their desk making stuff, which is pretty amazing. The downside is that the chip shortage has greatly affected all of these tiny manufacturers who don't really have the weight, I guess, of the big companies to get their stuff, because it's, they're a tiny market comparatively. So let's talk about some pros and cons as Eurorack as a format for making music. Pros are that you can make music that you'll never really thought about, never thought was possible. And this happens just kind of organically. Like, you'll be patching away, trying to do one thing, and then it'll end up sounding totally different, and you're like, not sure what's going on. And so you tweak a bit and you figure out what's going on, and then you learn about that, and then you can, use that sound or whatever. Like I said, it's also easy to use non-Western tuning systems, which is good because MIDI is good, but it's very European music specific. So with Eurorack, it's a bit easier to do non-Western stuff. And I'm sure everyone here will know that when you make a system, that the system itself is beautiful, how it works is beautiful. Same thing with Eurorack. Can be really rewarding to make a good patch. And then also there's an amazing community, people talking all the time on Discord and Reddit and everywhere pretty much. And it's just a lot of fun. The cons are that the signals are very loud. I kind of mentioned this before, relative to other gear. So if you have guitar pedals or have other things, going back and forth can be a bit annoying. There's also no memory because it's all just in the patch cables and in the knobs. So if you're working on a sound and it's really great, but you step away and then you have an idea for a new sound or a new patch that you want to try out, trying that out involves wiping what you had done before. And you could just write down every single patch and every single cable and every single knob position, but that gets annoying fast. Eurorack is also kind of optimized for certain kinds of music. It's not impossible, but it's harder to do music that has a really big build up and then a drop. It's more optimized for kind of longer running, more evolving music. It's pretty expensive, but at least personally, I feel a lot better spending a lot of money on, or like giving money to my friend for this module instead of giving money to like Apple, who already has $1 trillion. Like my friend is using this as their job, so I'm more happy to support them. But it is expensive. So just to wrap up, if you want to get started, the first step is to jump down the rabbit hole, do a bunch of research. There's a lot of great resources online, great videos, great tutorials that you can look into to learn more. And then also consider the type of music you want to make, because like a techno rave system will look much different from like a generative art, sonic art kind of system, as far as like module design and module choice. You can check out systems on modulargrid.net, which is a site that's kind of like PC Part Picker, if you've heard of that, where you can like, choose your modules and then save it and then see other people's systems too. And then just join the community, ask people what you think or what they think of your system that you're thinking about getting. Also consider full voices. Like, it kind of breaks the philosophy, but it's a really great way to start and to get into it and see if you like it. There's also VCV Rack, which is a software. It's like a software emulation of Eurorack, which it's good. Like, it's not as fun to use, of course, but it's a great way to like try out the system that you're thinking about. And then if you're local to the Seattle area, Patchworks is a synth and Eurorack store in Fremont. They have a bunch of stuff you can get hands-on, try it out, and then talk to the people and get advice there. They're really great, and they have a lot of my money. So yeah, just to wrap up, if you want a demo of all of this, you can come to my live set here in the Prime Dome tonight at 8. Also, Jesse and Breedex are doing a workshop on Pure Data, which is like a modular software language that's for audio, but is modular and a visual. I don't know much about it, but I'm looking forward to it. And then also come to Aaron's talk at 5:30 on Saturday for a demo of a full East Coast synthesis. The East Coast synthesis demo, which is kind of the demo side of this theory talk that I've just given. So that's all I have. Does anyone have any questions? Yeah. So I play, like, mostly I've played on Twitch. So like tonight will be the first time I've played Eurorack in person for people. I've played like tons of shows with other instruments and stuff before, but yeah. Any other questions? Yeah.
When you're playing live, when you're doing like something for are you hardware patching like between sections and things like this? Are you like messing around with the hardware, or is it kind of set?
Different people have different styles. Like, the question was, when I'm playing, do I like change the patch, like rewiring and stuff? Is that correct? Yeah. So different people have different styles. If you're like, generally the people that are like touring with it will have like their own patch that they like set because they don't want to be like unplugging and replugging everything in. So, and I'm kind of like that. Like I have like my system that I'll be playing with tonight is roughly the same patch that I've been using on Twitch and stuff for the last few months, and that what I'm actually doing is mostly controlling the sequencers and like choosing which scenes to go to and which patterns to play, and then also controlling all of the different knobs and stuff. But yeah, definitely there are other performers that start with a completely blank system and start from scratch. But yeah.
Aside from the expense, what is the most difficult part of getting it?
Okay. The question was, aside from the expense, what's the hardest part about getting into modular? I think it's just probably the learning curve. Like with things like Ableton Live, there's much bigger communities online and much more like tutorials and stuff. Where with like if you run into something you don't understand, there's probably someone who's written something about it or can ask someone about. But like if you're not if something weird is happening in your system, it can be harder to like debug that because like pretty much no one has the exact same system as you or has it patched in the same way. So you kind of have to know a lot of the theory and understand what's going on. But yeah, a lot of nuance, and especially with the like with the different CV voltage ranges, it's like you kind of have to know everything about each of your modules to play like perfectly. But for me, at least, that's part of the fun is like getting into a weird situation and trying to, exploring, figuring out what's going on and getting into weird places. So yeah.
Have you hooked up a mushroom? If so, do you know what the millivolt range on it is?
The question is, have I hooked up a mushroom and do I know what the millivolt range is? I haven't. I think it's pretty low. I think they have to like boost it a lot. But I haven't. Yeah. Someone back there.
So for that sampler that you were mentioning that would randomly select a segment within would it take that segment and just play as a trigger, or would it play it as like a slow LFO, or how would it interact with that sample, I guess? Yeah, so this is with the module is called the Mutable Instruments Clouds. It has a buffer, and there's a position knob where you can like choose the position in that buffer to for the sample to be at, and it takes a very small sample, and you can determine the range or like the size of that sample, but usually it's very small, and then it's controllable, but it will then play that sample in like, it's just very, very short samples, so just like or something like that, but usually very, very fast. So it's playing them at like audio rates, so you hear it like as a tone. I don't know if you've heard or seen the video for the Swedish House Mafia's song 1, but that's a really good kind of demo of it, because they take a kick drum and just keep playing the kick pattern faster and faster until they generate the bass line to the song. And that was a generative synthesis. Generative synthesis bass line. Or not generative, granular synthesis. Sorry. Yeah.
Oh yeah, just more inspiration for biofeedback related things. Modular, I just know who like do brainwave amplification and control parameters on a modular, trying to control their like alpha data waves in their brain.
Yeah.
So that's a fun way to, hands free.
Yeah, that's like a whole like world in modular, is just like weird ways to control it, because it's just analog. You can kind of do whatever. And I think we are at time. Okay. Yeah. Thank you everyone for coming.
And as per usual, if you have any more questions, think of another question. The speakers will be reviewing the Discord speaker question or talk question channel. So please post your questions to the Discord if you think of them later on.
Do you want me to? Oh, sorry.
It's just gonna grab.
David, this goes to you.
I need to. Go anywhere. Can I? Yeah, I need to. Can I charge this at the same time?
I believe so.
That's not.
This shows power.
Yeah, yeah.
We will make it work.
Okay, well, can you put this end somewhere
Very
useful
small.
as well?
I'm here, so I capture. And then here.
I did, yes, and I will log into this.
Okay.
Okay. Yeah, I know him.
Are you getting power?
I am getting power, and I'm also hopefully, it says pre-select video source.
We are working on that.
Okay, that's fine, we can do that. Well, I'm ready when you are. Bah.
There we go. That's got it.
Yeah, I can read.
Is that for me or them?
You were working on something.
That's fine. So hopefully this will be, that will be display.
It will show up in a moment.
Okay. So I've got a separate. Is that for me? Is that I'm not seeing that on my screen at all.
It's a Mac.
Display is fine.
It's a Mac. So I don't think either of those are.
Yeah, exactly. That's not.
So it's it's on a desktop.
What am I supposed to? Can someone? Do you know what to do? 'Cause I do not.
Let's see if we can figure it out.
Okay, so I've got this is what I want on there, and then you know what you're doing. Oh.
I take suggestions from other people as well.
What are you trying to do? Hang on,
I'm
it's on.
trying to drag
Hang
the
on,
window
you
to
can't do
another.
that. Yeah, that is. On here.
There's the ability to close it.
Yeah. I just was. There we are. So, but it's still not.
Okay, we're going to go to here.
Yeah, we can go to here.
And
I don't remember if that's spaces.
Here's display.
let's hit gather windows.
It's an issue with
Here we are. What's this?
spaces or something.
Here we go. Here we are. So what's this then?
That's
Rotation.
the- No, it's not a monitor issue. It's an issue with, I think it's called spaces.
Okay,
Which is designed for separate work
Do you know?
spaces.
Yeah.
And I have honestly avoided it from day one because I hate it.
Okay.
And so I don't know the keys or anything. I don't know the shortcuts.
Well.
Our night shift airplay display. Do we have anybody in
Here,
the
What's this?
let me take a look.
arrangement? Mirror displays.
And what's this?
Okay.
Yeah, but I don't want all of them. So I actually don't want it to be mirrored though, because I want my notes on my.
Yeah. Oh, okay.
Yeah, I don't want it to be mirrored.
Oh, I'm
Because
sorry.
because basically,
Where from that work?
so is this up there?
That's your other display.
Yeah, but there's no other display. That's the thing I'm saying.
I think you can move the
Oh, I
window to the window.
see. Hang on, wait a second. Hang on. How about if I do this? Yep, I got it. Here we are. Got it.
There are some.
I found it.
You drag it over.
Yep, I've managed, but it's far away. Ah, it's weird doing it backwards.
You can change the position if that helps. You drag this one. That's
Well, at least the slides are working. Yep, that's what I'm trying to do.
It's a trick.
It is a trick. Yay! Here we go.
Oh, good job.
There we go. Let's get my glasses out.
Okay, before we get started, the usual announcements. There's a community spa session tonight at 7. Normally the spa is booked by groups. They do that because they clean in between them, COVID, all the rest of that. But there is a community session that is has some availability. $15 for 50 minutes. You'd have to, I think, go to the Doe Bay site to get on the reservation system for that to add yourself. But there's one today. There's the restaurant on site if you're getting sick of cooking. We basically own the restaurant for the entire weekend. No one else from the island can use it. The food's quite good. It's actually one of the nicer places on the island. They got great food, great drinks, so you can either make a reservation or I think they're doing walk-ins also. And I think they're doing breakfast, lunch, and dinner. So, well, not all at once. I mean, separately. If you have not yet gotten a New Relic Nalgene bottle, they're in the back by the soup. If you've already got one, please don't take another. Like with most things, we only have just enough, so please don't take duplicates of anything. But you can you can fill your bottle there with soup if you want. We of course have the music starting after this talk. The speakers themselves will be addressing any questions they can't address here or that you think of later in the Discord speaker or talk question channel. Check that out. The lost and found is where things that are lost go and where they're found by the people that own them eventually. If there are spare children that are lost, you can take them there, throw them in the bin, and then hopefully their parents will come by and collect them at some point. If you have a dog, pick up after your dog. If you have a dog here, you're part of the dog community, which means be responsible. And if you see something, don't just stand there and say, that's not my dog. Pick it up. We've had a little bit of an issue with that. We do have the Voight comp testing. If you're unsure as to whether or not you're human or replicant, that's occurring 3 times a day, 3 sessions a day. 1 in the morning, 1 in the evening, and 1 in the afternoon. The morning one is geared to be more social distancing. So if you're at all concerned, you should go to that one. But otherwise, it's just walk in. There's a little waiting area there if there's a line. But it's, I think, 2-hour sessions in each time throughout 3 times a day. So there's actually a poster right back there that has the hours on it, but there's also hours in front of the black tent that says Voight comp testing. So check that out. And I think that's about it. Of course, if you're not feeling great or if you do test positive, please mask up, isolate, but let a staff member know immediately. And we'll gladly set you up with entrance for next time around, 2024. But we just want to make sure everyone's taken care of and just be mindful of those that are around you. I'm supposed to remind people to stay hydrated. So stay hydrated. And once again, soup does not count.
Yeah, Yeah, it does.
But other than that, I think we're ready. Are you all dialed in?
Yeah.
All right, so Helen's going to be here talking about soft electronics, so please welcome her to the stage.
Hi. Can I just take this off the stand? Is that all right? I always just bash myself in the face if I use one of those, or I just manage to not talk into the microphone, so it's safer in my hand. Hello, everybody. My name's Helen. I'm going to be talking to you today about the softer side of hardware. Hardware is the love of my life, but I do like to mix it up and make some of it squishy for funs. And I thought it would be fun this talk has like two aspects to it. Number one, I'm going to give you some hands-on advice about how to get started from what most people come into soft electronics through basic use of conductive thread, so electronic embroidery. So I'm going to kick off the talk. Well, I'll tell you a little bit about my work as well, so you've got some context. Then I'm going to kick off the talk proper by talking about electronic embroidery, give you some practical tips for getting started and some resources. And then the latter half of the talk is kind of a whistle-stop tour of all the different types of soft electronics. Obviously not exhausted, but I did want to give exhaustive, I should say. But I did want to give you a little peek at a few different things. So we're going to have a little look at some e-textiles, what that means. We're going to talk about soft robotics and what that means, and a little bit of flexible circuitry as well to round it off. So hopefully we'll give you some fun things that you might want to go home and try and get some inspiration on how to look slightly differently at hardware. So before I get going, I'll introduce myself slightly. I'm a recent immigrant to the US. This is actually my first US hacker camp, although I am a EU camp regular. Have I got any Europeans in the house? Hi. Nice. Yeah, cool. So I'm very happy to see some Marto here. So it does feel like we are actually in a hacker camp. So I'm in the US because I've got a job at Crowd Supply, which some of you may know. We are a crowdfunding company for open source hardware owned by Mouser Electronics. So that's why I'm in this country. But before I came here, I was also making hardware in Berlin, basically. So let me and my Twitter handle's there, and then there's my email address. And then I'm also, like, a bunch of the stuff that I talk about is also, I do try and put most of my own projects up on GitHub. So if there's anything that particularly tickles your fancy, let me know, and I'll make sure the code is available for you. All right, then, without further ado. So I spent many years before I moved to the US to go and work for Crowd Supply. I spent many years as a writer and a professional maker. So I wrote for Make Magazine. This is actually I had a column on hardware for Make Magazine. This is a still from one of my books. This is a children's book on crafty. It's like teaching electronics through the medium of craft. And I actually wrote this with an advisory. Words, Helen. I actually wrote this with an advisory board of 150 girls who chose every single project that went into the book. And that's what really kind of got me into sewing with electronics. Like, I'd done some work on soft electronics before for my own kind of curiosity. But the research and workshopping for this book really made me notice this switch in my audience. It was the first time I'd really explored this topic in depth. And it was also the first time that I'd explored teaching basic concepts of electronics through the medium of craft. So I'm not going to go deeply into my pedagogy here, but I will say that running workshops, teaching basic electronics concepts with a standard through-hole, learn-to-solder kind of or DIY robot kit versus a sewing circuits kit is completely different. Same skills, you're still learning the basics, simple circuit, parallel circuit, what an LED is, maybe add in a sensor or two. But the medium, instead of fiberglass PCBs, we're using felt and thread here. It changed the demographics and it changed the vibe completely. And that was really the first time I started really noticing this. And then after that book was published, I worked on another project that put technology in the context of craft that had similar things. So this is the Minimoo, which is a DIY, that's my hand on the box as well. This is a wearable instrument that I designed for Imogen Heap and P. Maroney, who are the British Adafruit. And the kids code and wire and sew this glove. Anyway, like workshopping this product gave me a lot more anecdotal evidence about how mixing craft and technology really appeals to teen and tween girls a lot more than the standard like robotic car style kit, which I guess is probably not a big surprise to anybody. But also an interesting thing here was when this was workshopped, because part of this was coding, part of this was electronics, and part of this was sewing, but because you start sewing first, the people who were in the class who were actually quite good at sewing finished the glove part of the workshop first and then got onto the coding and hardware before everybody else. So it kind of gave them a bit more time and it gave them a confidence boost at the beginning as well. I'm not going to talk too much about this, but it was just an interesting, this is when I started getting interested in kind of the effects of teaching hardware through the medium of craft. And then the final strand of my own personal work that I wanted to introduce to you is instrument making. So when I'm not making things for other people, like then I tend to make instruments or sound making devices, really. And I like to make for my instruments, all of my instruments, I like to make things out of experimental materials, so including electronic embroidery, but also like architectural or flexible materials. And I just wanted to give you that like final piece, just like this is kind of I'm not like the number one expert in sewable circuits. I've just made a lot of them. I've taught using craft through electronics a lot. I've used it a lot in my own personal work, and I also like it in the context of instrument creation. So that's kind of where I'm coming from here. So let's move on to electronic embroidery. So when most people think about electronics, they think about wires and boxes and maybe even stiff fiberglass circuits, PCBs, printed circuit boards. But the wires in those boxes and the traces on the circuit boards are all just paths for the electricity to move along. So by choosing a different material to make the paths for our electricity, we can make lots of really exciting and unexpected electronics. So this is a very simple thing here. This is a simple circuit on an embroidery hoop. And I would say if you are thinking about teaching electronics using sewing, embroidery hoops are a really great way to do it because you can check the bottom and the top. They're very cheap. They're easy to work with. And you can see mistakes really easily. So for those of you that aren't, who here has made a circuit before? Actually, let's get a little. All right, so the vast majority of you. Okay, good. So I won't spend too long explaining a circuit. But here we have like this is a sewable component. This is just a battery pack with a coin cell battery that's got the power inside of it. And then obviously off it goes, the electricity off it on its merry little way up to this first obstacle. This is a sewable LED here. And then you can see I've taken the path of the wire in a nice windy fashion back down to the other side of the battery, thus completing the circuit. And this is just a very, very simple example of what a simple circuit looks like when you put it in a sewing form. So that is the most simple kind of sewable circuit that you can get. It looks like that. I want to spend, I could talk for a whole hour about this. I'm such a dork about threads. All right, so the conductive threads and conductive materials are the starting point for like most people who want to start experimenting with soft electronics. So I'm going to spend a little bit of time here guiding you through the basics of choosing thread, because if you choose a bad thread, you're going to have a bad time, and to tell you some of the most common troubleshooting tips, just to kind of really get you started. So let's move on here. I'm going to come back to this slide and tell you which one's which, but let's move on to this information thread. Okay, so these are my three broad sections of the different types of thread that you get on the market. You get what I'd call the fluffy thread, which, let's see, we've got here. It looks like this. This is kind of a fluffier thread, and basically when you hold it up, it might look like this. This is a fluffy thread. So basically think about this as a wire, right? And if you've got a fluffy thread, these little wires all stick out. So they're little threads. So you have to make your traces far enough apart, or they will create a short circuit. because if you zoom in, that's like a short circuit nightmare. So that's like the fluffy thread. It knots super well. It's quite easy to work with, but you just have to be really, really careful to keep your paths away from each other. Otherwise, you're going to get that short circuit situation. My top tip there is I use hairspray after I've finished a thread. If I'm using a fluffy thread, I'll put a bit of hairspray on afterwards, smooth it down, and that will keep most of the flyaways in place. And stop you getting short circuit. Now, the other major type of thread you'll find on the market, and more, this is more common, is this kind of like what I call like a waxy feeling thread. And like all of Adafruit's threads, I would say, fall under this waxy kind of thread. Let's come back here and I can see. Yeah, so this is like a waxy type thing. I mean, it's not a great picture, but you can see that you can even see on this picture, so this is the fluffy type, you can see it's got little hairs, and this one, it really doesn't. So you're not going to have to worry about short circuits on that kind of thread, but the knots do like to come undone on that kind of thing. So my top tip, if you are using waxy thread, you can use a drop of clear nail varnish to seal your knots afterwards. Then we've got the third type, which I call is kind of like the more advanced style, and this is a copper. You get pure copper and pure silver threads by a German thread manufacturer called Carl Grimm. These are the only ones on this whole thing that are solderable. All of these you cannot solder. This is solderable because it's stranded silver and copper. It's extremely brittle and annoying to work with, but it is absolutely beautiful. And I do have some examples of all of this afterwards that you can have a look at as well. So, and then my favorite. So these fluffy, we've got waxy, we've got the beautiful ones that is very difficult to work with. But then this one, the Madeira HC range, and I normally finish with saying you can't get that in America, but no, you actually can. You can buy it in America, which is very exciting. So the Madeira HC, which is high conductive range, is the gold standard for thread, I would say. I've tried pretty much all of them on the market. All of these are not specifically made by an embroidery manufacturer, but Madeira is an industrial embroidery manufacturer. So they make threads for industrial applications, like automotive and like proper like. So, and they've just come out with their first range of conductive stuff, and it's really, really good. That's what I use. And the cool, actually, that's a good thing to tell you. Nope. So this is the Madeira one, that's my favorite. So the waxy ones, you can use them in a sewing machine, but you can only use them as a bottom bobbin. You have to use regular thread as the top. This fluffy stuff, don't even try, you're going to have a really bad time. This Madeira stuff, you can use in the top and the bottom thread in a sewing machine. You can use it exactly like normal embroidery thread. So like this is one of my projects here that I've embroidered with a machine. It's like a zigzag embroidery all the way down, top and bottom, using that Madeira. But until that Madeira came onto the market, that was not possible. So those are the threads on the market. And then so those are the two big things. So when I'm teaching workshops, there are two huge things that people don't think about, and I wanted to just quickly talk about that. So these are the two common mistakes, loose connections or dangling knots. So when you're adding a sewable component onto your piece, you need to have a super tight connection. So maybe like 3 looping stitches. Something like this will not complete your circuit. I mean, I think you probably know this. All of you know about hardware. You need to complete a circuit in order for it to work. And here, this is why I say to use embroidery hoops if you're teaching this as a workshop. If you flip it over, it might look beautiful and neat on one side, but on the underneath, you know, obviously these connections, you're creating a short circuit. And if we know anything about electricity, it is lazy. So if it doesn't have to go over an obstacle, it won't. It will create a short circuit. So make sure you watch out for both loose connections and dangling knots. All right. So those are my top beginners tips, like very, very, very kind of light touch beginners tips for this. It should get you started with embroidering electronics for your first project. And I wanted to put this picture up here just to take you through some more advanced techniques that you might want to consider if you move on in your electronic embroidery journey. So actually, this is a project. I got this with me. It's not working though because it sounds terrible. So it's on purpose. So this is a project I made a couple of years ago. It's a riff on a noisemaker made by a Dutch artist, and it was like one of the first electronic PCB synthesizer. Not synthesizer. It's a noisemaker. It's called a Krakdos but this is a noisemaker, but it's fully embroidered. Anyway, there's a couple of techniques here that I wanted to point out. One is here. This is a little ceramic capacitor we got going on here. So you can make pretty much any through-hole component into a sewable component with a pair of needle nose pliers. All you do is stick the end of the leg of the through-hole component into the tip of your needle nose pliers and then wind it round and round, and then you get a loop that you can actually sew to. Now, ceramic, it doesn't matter which way round you go, but the electrolytic capacitors obviously have polarity. So the way I do that is I just put a little bit more of the leg through the needle nose pliers. So it's kind of like instead of being a loop, it's a loop with a cross through it, So I use the loop with a cross through it for the positive. So that's how to make any through-hole component sewable. And then this is another thing that you might want to know as well. So I am going to talk a little bit more about this kind of thing. So this is a flexible circuit. There's a flexible PCB, I should say, sorry. And this is we're going to go into flexible PCBs in a little more detail shortly. But basically, I've used it here as a breakout board for a chip. Now, sewing a chip into an embroidered piece is very difficult because I have done it where I've individually soldered the legs of the chips to copper and then sewn with it. But if your chip burns out, you've got all of your embroidery and nothing's working, and you're just very sad. So what I do is I solder a dip chip socket onto a flexible PCB. These are that we've designed, and then you just put the chip in and you can take it out and switch it out if necessary. Now, the important thing here is if you are going to design a PCB for sewing, I would recommend that you use flex because it's very thin. We like that. But also, there's this here. So we've got one row of holes that are electrically connected to the chip, and then there's a second row of castellated holes on the edge. Now, typically you use castellated holes for all sorts of interesting things in normal electronics, but in sewable electronics, castellated pins are great because you've got something to hook your thread onto, so you can create these nice, neat, so you got the full circle and then you got the semicircle, and that's like the castellated edge there. That's not electrically connected, it's just like mechanically helpful. So that's that. Oh yeah, this is a good, so these are some advanced techniques that you can use for making embroidered electronics. If you like the sound of this and would like to know more, there's a wonderful reference called Cobacant, which is basically like the Bible of wearables. A little bit dated now, but there's some incredible projects and techniques there. And that's Kobakant, run by a pair of women called Hannah and Mika in Berlin in Germany. And I'll show you a piece of their work later, but their work is incredible. But they've got a wonderful directory with all sorts of different, like how to connect different things and what different materials. As I say, it's a little bit dated now, but there's loads and loads and loads of really great information on there. And I will tell you about them again later because they're very important. Now, before I move on to e-textiles, I wanted to give you a couple of examples of how it's actually being used. So this is a close-up. I did not make this. This is beyond my skill level. So this is an example of what I would call very advanced electronic embroidery. So there's an artist called Irene Posch, and that's Posch, and she built this. This is the embroidered computer, which is a programmable 8-bit computer made using traditional embroidery techniques and materials. So you've got gold here, which is laid down. These are the traces, but it's laid down using an old technique called couching. And then you've got each of these bits here is a magnetic bit that flips backwards and forwards. So it's actually like a physical computer. And this is only a close-up of a small part of it, but they've got the entire computer across this giant thing. So I'm sure it's really, really worth looking at that if you're interested. The other thing I wanted to say about electronic embroidery is how it's maturing, because that's very exciting. It used to be a little bit more of a niche technology, you know, like academics, DIYers, artists, weirdo hardware people like me, who saw the potential of using like flexible substrates, or they thought it was just fun. But now, like new materials and new machines, they're bringing it much more into the mainstream, and particularly industry. So this is a picture from, I spent 2 weeks working at Microsoft Research just before the pandemic hit. And I was lucky enough to get to see this bad boy in action. This is a ZSK industrial embroidery machine, which sounds like a machine gun when it's going. It's like, it's so fast. Like this is like legit industrial stuff. And this is loaded up with this Madeira thread that I was talking about, and this was the first time I'd seen it used like this, which is really exciting. So these pads, this is a piano here, and this whole thing was automatic. Sorry, this whole thing was automated. So all of these pads were automatically things, and even more excitingly, this microcontroller, which some of you may recognize as a Circuit Playground Express, that was also automatically sewn in place using an industrial machine. So I think we are going to see a lot more actually exciting things happening in the e-textile space. So very cool. Oh yeah, this was another cool thing as well. This is like, you know, it's on the verge of being real. So like, I mean, I'm not going to go too much into it, but when you're taking something from DIY and you're trying to put it into industry, you know, you've got to like. Industrial embroidery is not set up to make circuits. You know, these big factories don't have the embroidery in place equivalent of a pick and place machine, right? We need to have LED sequins that will fit within industrial embroidery practices before they can actually start working. So these are some experimental pick and place LED sequins, which I thought was quite cool. And it's not just LEDs as well. This is RFIDs. We're talking antennas. We're talking like Bluetooth. All of this kind of stuff that all fits on these things. And then one last example, because I thought this was kind of fun, actually. This is what we call moss embroidery, which is like a chenille fabric technique. It's like how they make rugs and towels and so on. And the tufts of this thread are pushed in and out of this substrate material. And so all of this then is comprised of the same thread that's looped. Loop. So this is used in medical. This is currently used. This is not like experimental. This is currently in use. So this is like how they're making it, but it's an electrode, and they use it to monitor all sorts of things, but it also can like output stuff. So basically, if you integrate this patch of like conductive moss embroidery into a compression garment, it gets even more conductive because the loops get smushed against the skin as you put them on. So it creates these like form-fitting electrode garments. So they use it for like monitoring babies or people who can't handle the glue that you normally stick electrodes on. Anyway, I thought that was kind of cool. It's also used in automotive and blah blah blah, but that's less exciting than chenille electrodes, I thought. Anyway, that's cool. Fabrics. So the term e-textiles is thrown around, and it's used very generically, and I don't feel like it's massively useful anymore. So I'm using it here to kind of refer to conductive materials that have cloth-like properties. You can find this you can hear it called conductive fabric or EMF shielding fabric, and there's lots of places you can buy this online. So Adafruit has got a decent selection of experimental materials, but there's also an American website called lessemf.com, which has a lot of different materials. There's a nice intersection there between people who like to wear tinfoil hats and people who like to sew with e-fabrics. Yeah, because it's generally those people who are, that's lessemf.com is not an e-textiles website. It is a website for people who are, yeah. But anyway, they have good materials. Or of course, like Alibaba and so on as well. But yeah, so there's all the. I should tell you some of these. This is one of my faves. This is actually conductive Velcro. Who knew? You can get that. You can. It's very exciting. So these are two different types of conductive material that you probably need to know the difference between. So this is woven and this is knit. And the difference between a woven fabric and a knit fabric is the yarn or the thread that composes them. So a knit fabric, and when you knit, if there are any knitters in the house, they will know it's made up of one single yarn which is looped continuously over itself. Whereas and that's the knit one, and there's a woven fabric is you cross things at right angles, basically. So it's like they're woven together, and the physical material of the material changes a lot as well. So if you can imagine. This one is stretchy because it's of the way the knit works, but this one is not stretchy at all, but because there's no looping in order to stretch it. But it also has different electrical properties. So the knit one, I've got to check the things here, right? The knit one has 46 ohms per foot across the rows, which is the stretchier direction, and 460 ohms per foot across the columns. And that's because the knit is comprised of so if you think about it, the signal will be going from here to here, but in order to get from here to here, you're going a lot further. Basically, you're going around the houses. Whereas the woven has got the same level of resistance on both sides because you've got the same length of thread, which seems obvious unless you don't know it. So that's something to work out for. Both of those are from Adafruit. This is a great material that you should have on your list. This is Velostat, which is a pressure-sensitive material. So squeezing it reduces the resistance, so it's great for making flexible sensors. And it's much cheaper than buying off-the-shelf flexible pressure or bend sensors as well. Great thing. I made a pair of meowing yoga pants out of that, obviously. These tapes are great for prototyping. Copper tape is everywhere. I hate it. I would consider cutting copper sheets with a vinyl cutter. So I don't use copper tape that often because it rips all the time. This is actually like a nylon conductive tape that I use. It's much more reliable. It doesn't break, and it's also kind of cool looking, in my opinion. So you can get them. It's from Adafruit again, or it's called Brown Dog Gadget sells it, called Maker Tape. And these are it's just, silver tape, isn't it? I don't need to explain it more than that, do I? Another tape that I wanted to throw out there, because not a lot of people know about it, but it's a really cool tape. It's something called Z-axis tape, or I suppose you'd call it Z-axis tape. And it's conductive tape that's only conductive along the Z-axis. And it's what Bunny Huang chose to use in the Chibitronics stickers. So only one or two of you will be interested in that, but I wanted to throw it out there because it's an awesome tape and you should know about it. There's also an honourable mention here for felting. I don't know how to felt, but it does exist. This on the lower left here. This is like a felting, stainless steel felting material. So it exists. If you like to felt, go and play with it. I have some. I've never used it. So that's fabrics. Oh, this is a fun one as well. So just wanted to put a shout out for this talk. So I don't know if any of you went or virtually attended the Open Hardware Summit this year, but Dr. Anuradha Reddy, she did an awesome talk about open hardware called Naughty Hardware. And this is a lenticular crocheted towel that she made. So that's an interesting thing. And then here's the Kobakant slide that I promised. So the Kobakant with the German... it was the German DIY people that has got like this Bible. And this is actually one of their pieces. I was lucky enough to see this in person. So as well as the DIY stuff, they also have like a couture electronics studio kind of thing. And this is one of the pieces they made. This is actually a morning dress. So these here, these spirals made of silver, they're actually functioning speakers that have been embroidered into the dress. So when you wear this dress, it wails for you. It's like hiring a morning person. Not morning, M-O-R. M-O-U-R. So yeah, take a picture of that. If you take a picture of that slide, this has got lots of great information on it. Thank you, Hannah and Mika. Moving on, I wanted to tell you a little bit about flexible circuitry, which is newly and excitingly accessible to tinkerers like us. So the substrate of a normal circuit board is made of fiberglass, and a flexible circuit board is made from a substance called Kapton. And another cool thing, a really cool thing about flexible circuitry is that instead of routing it, so normally when you're cutting out a board, so you're making the shape for your board, you're using a drill, right? So you're routing it out. So there's certain you can't get certain angles and so on. However, a flexible PCB is laser cut, so you can do whatever you want. So that's a very exciting thing. So it's been, flexible circuitry is not a new thing in industry. It's been used a long time, but it's only made its way to the maker world reasonably recently. Thank you, Oshpark, for making it cheap and available. So Oshpark, who, if you don't know, they make circuit boards. Yeah, it's really awesome. I've got some flex with me, I think. So if you want to have a little look at it, that's later. Oh, if you are interested in flex, I would highly recommend you either follow this guy, Carl Bajaga, or he's got a really good YouTube channel as well. He does loads of flex experiments. So would highly recommend you take a look at that. Here's another example of flex being used. So a lot of some of the practical reasons to use flex is, well, it flexes. It's very thin. So in this instance, this is one of my favorite hackers, Joey Castillo in New York, and he made this sensor board watch. And what he did is basically you take the internals of this Casio out and you replace it with his board, right? So it does stuff. But he's used flex here because this is very space constrained. So he's used flex here to add in a daughter board, a sensor board for the main microcontroller here. So that's pretty cool. So there are some design considerations that I'm going to very briefly run through, but there is a minimum bend radius, for example. You might want to use, when you're doing vias and pads, the best practice is to use teardrops instead of a circle with a line going into it, because a circle with a line going into it causes angles, and then that's the mechanical stress. So it might splinter. Whereas if you've got a teardrop going into the via, you're going to have some mechanical relief there. Another thing you should think about is maybe stiffening. You can stiffen so this is very flexible, but if you want it to kind of semi-flex, you can put a copper pore on it to make it a bit stiffer. And then one thing to watch out for is components do pop off if you're flexing a lot. So be wary with your placement and be realistic with your design. I use it a lot for electrodes, particularly for my CapTouch projects. It works pretty well. I believe that those are my tips for flex. But there are, like, if you Google Oshpark and flex, there's a bit more information on like design considerations there. All right. Oh, here are some examples. This is one of the things I made. So this is a flexible vocoder I made using one of my favorite microcontroller boards. Well, single board computer, really. But yeah, that's just an example. And here, this is why I put it here, mechanical stress relief. So when you're moving things around, you remember I said like the teardrop, because it pops off. Ignore, I have not used teardrops here. Please ignore. But here, this is a second row of holes here, and these are not electrically connected. This is here to provide strain relief, because when you're moving stuff around, if it will break the solder connection if you don't add mechanical strain relief. So add like a second row of holes and it will help you. It's just such an ugly color though, isn't it? I tried to make it slightly better with tape on the background, but it still looks terrible. Oh well, Kapton, it's not attractive. Who knew? All right, moving on very quickly. Our whistle-stop tour of squishy electronics is soft robotics, one of my favorite things. So this is what we're looking at here is a giant sculpture. This was actually earlier this summer I was at EMF camp, which is like toorcamp but much bigger and in the UK. And there were loads of these types of things everywhere. So these are electronically controlled, expressive, soft robotics that are kind of sculptural. Basically, the way that this works. So most soft robotics is basically used on pneumatics, right? So you're just putting air places. You're putting air places is basically what soft robotics is. Not all of it, but yeah, lots of it. This particular is. So here we have, like, this is, they've sewn this big creature, and then these are actually the things that are operative. So basically, all of this is filled up with, like, bouncy castle air stuff. So you can just buy off of eBay, like, bouncy castle air providers. You sew this, and then these vents open and close based on, code. And they actually move things around. So it's basically controlling the flow of air, makes these really cool giant sculptures. But that's Air Giants HQ made those. Super cool. I thought that was a nice example of like artistic use of soft robotics. Anyway, let's talk about it. So conventional robotics, is typically made from rigid parts, which makes them vulnerable in a number of ways. And it also means they're not as flexible as, they can't squish past things if they've got a defined shape, they can't move around. But increasingly, like, scientists are building robots made of soft, elastic, plastic, and rubber, and designs that are inspired by living, moving things. So this is an octopus bot, which is a squishy underwater robot with 8 limbs that bend in every direction, and it's got a pneumatic control core. So basically, when it swims, it fills this expandable mantle at the beginning, at the front, with water, and then it expels it out the back. It jets it out the back to move forwards. And then the limbs here are also it will be able to stiffen each of the 8 floppy limbs in sequence to crawl forwards. And then when it wants to go through a very narrow space, it can smush all of the water out of itself and then get into a very tight space whilst largely deflated. So a normal robot would not be able to do that. So this is very exciting kind of research. I think it's the University of Minnesota belongs to this one. I will check it and get back to you. So this is a good entry-level way into pneumatics. This is a guy called Tinkermind on Twitter, a really nice person. And this is his Arduino-compatible pneumatics experimental thing. It's called Programmable Air. It's not always available, but it's a DIY. Basically, it's this guy who's made it himself. But it's cool. It's a really good way to get into it if you're already familiar with Arduino as well. So yeah, Programmable Air, worth having a look at. And then finally, good, we've got 10 minutes. Good, I'm about on time. So I wanted to talk a little bit about the concept of softness in robotics. So this is a tentacle project. I did bring it with me, and it is working, so you can have a go later if you'd like. So this is a tentacle that I made when I was really depressed and anxious. And I wanted to create something that wrapped around me and had like a physical, comforting presence. And also did something that's comforting. So basically what happens here is I've machine embroidered silver thread down the inseam here, and it's filled up with squishy stuff, and then and also some normal electronics. But basically what happens is I wrap it around me, and then when I stroke it, it purrs in a really calming, bassy manner. But it was just, I wanted to experiment with like something as hard and feeling as electronics, giving me something comforting and nurturing in a way that you don't necessarily normally associate with electronics, I guess. And it was very, people like to cuddle it. It's actually very comforting. Like weirdly so. It is. It's with me and it works. Unless the batteries run out in the last hour, in which case, tough. You can cuddle it still though. But yeah, I just think by putting electronics in the context of something squishy, it kind of really changes the feeling of it. What have we got here? That looks like what is this? Oh no, we're not doing that. No, we're not doing a video. Okay, move on. No, we're not. No. Thank you. This is funnier. Anyway, so earlier I talked about, you remember that like felt glove for kids that I made for Imogen Heap and P. Maroney, the like wearable. So this is exactly the same technology, except I've just worked with an artist in London to make a fully leather version of it. It's like an elbow length glove, which I also have with me. Do I have it in my bag? I do. Look at that. Here is my elbow length leather glove with a children's microcontroller in it. Now, let me tell you, I think people got very different context clues from that technology being in an elbow-length leather, black leather glove, as opposed to a very pleasant turquoise felt. You know, so it did exactly the same thing. It used almost exactly the same code, but the material choice completely changed the project. I got some pretty interesting DMs too. Yeah. But actually, this one, this was. I did this to control my herd, several of my herd of robot unicorns. I went through a phase of making robot unicorns out of different materials, and this was my leather one. But it made me feel like such an evil commander. I was like, forward, go, because it was all gesture controlled anyway. But this now, and this is on my GitHub as well, so this now does not control robots anymore. It controls a synthesizer on my computer. So basically, by moving my hand up and down, I play different sounds triggered on pure data, which I believe there is a workshop on this weekend as well. And all of the code, all of the patches for that is up on my GitHub if you want to have a go at that. But yeah, it's that was fun. Yeah, triggered all sorts of interesting sounds. Yeah, pretty cool. And then because we have exactly 6 minutes left, I've got a bonus slide that I wasn't sure I was going to get to, which is my favorite microcontrollers and single board computers. I haven't talked about anything to do with microcontrollers yet. But here's my favorite things. If you're getting started, Adafruit, Circuit, Playground Express, and the Microbit are excellent choices for people, young people, artists, or people who are simply not familiar with either code or hardware. These are great kind of controlled ecosystems to get started with. And also, and the reason I put them on the sewable slide is both the Adafruit, Circuit, Playground Express, and the Microbit have large pins, which means it's easy to sew to. So sewing to a teensy is possible. I have done it. But it's a bit fiddly. So starting with these larger pins are useful. Now, as you're going on, my favorite advanced combination is Bella and BeagleBoard. So BeagleBoard, for those of you who aren't familiar, is an open source hardware single board computer. And Bella, I am an endless fangirl for Bella because they're a group of academics in London who really make amazing experimental instruments. And as part of that, they make these really great boards. So it's like an Arduino's got a shield, Pi has got a hat, isn't it? And then the BeagleBoard, they call them capes. So Bella's a cape for a BeagleBoard. And what it does is it means you can save your pure data patches directly onto it. It's got the lowest latency of any system for embedded electronics that I have personally found. And you can either code it with C++, and if you're interested in that, this is why. So Leading Zeros, her GitHub, Becky Stewart's done loads of really good workshops on coding the Bella with C++. But anyway, so fangirl of those, worth checking out, especially if you're into music stuff. Solder Party is a Swedish hacker called Arturo. He often makes boards with castellated edges, which I adore, as I said, because it's easy to hook your things on. And then but these are not specific to sewing. These are specific to sewing. The last two here. So Make Fashion, I think they're based up in Vancouver in Canada, actually. Or, they're certainly Canadian, that's for sure. But they've got some really great boards, but they've also got really great plaited cables that are really stretchy. So I check out them. And then Leah Buckley, I wanted to give her a big shout out because she was one of the, she's one of the first people to really popularize the idea of sewable circuits. And her brainchild was LilyPad. Which still lives on. So there's a whole bunch of LilyPad stuff that you can look at there. I would say that now that uses the Arduino ecosystem, and this is using more Circuit Python, but you can still use Arduino. Microbit is MicroPython. So it depends on your weapon of choice with code. But LilyPad is Arduino, CircuitPython, MicroPython. So yeah, those are my favorite things. And that is me. I've got 3 minutes to spare, even though I was late on. Brilliant. Would anybody like to ask any questions, or should we do this outside? Questions, let's do it. Let's see if I can answer. Did I go too fast? I'm sorry, I'm Welsh. We do speak quite fast. We do speak quite fast. And my accent's probably confusing, but oh well. Sorry. Who's, if, hand, oh yeah. Synthesizers ever? Or I don't do modular synthesis because I've historically been quite poor. And I've moved a lot. But yeah, you totally can. There's lots of people who've hooked up various sensors to, I mean, if you can make it not wearable, you can make it wearable. I mean, there are design considerations. Sorry? Oh, that was a walkie-talkie. That was not a heckle. Good. So anything you can make, pretty much anything you can make that's a reasonable size, you can make wearable. I mean, just be careful with LiPo batteries, please. I mean, I don't actually use LiPo batteries. I use those phone charger batteries you get, you know what I'm talking about. Let me show you. Like this kind of thing, like a USB. So I all my wearable projects, I do not use LiPo on my body. I just use USB power for all of my projects. Don't put LiPo on your body. It is not worth it. We don't want exploding hackers. Hello, what's your question?
Which one do you like to use the best?
Which one, sorry?
Which one do you like to use the best?
Which one of which? Of what? Of my projects?
Yeah.
I like the tentacle best. Oh, also, I've got an embroidery hoop microphone that I brought with me, which isn't sewn, but it is embroidery themed, and you can sing into that later if you like. I even brought a tiny little amp with me. What type of what? Sorry. What?
Which one that you showed on the screen is your?
Oh, so my favorite looking one is the Cracklebox, the fully embroidered analog synthesizer thing, but it sounds terrible, so I don't plug it in. Cracklebox, it looks lovely. Well, it's true. Like I'm like the sound. I'm of the opinion and sound, like controversial opinion of by sound artists standards of like music should sound good, but I know that's passé. Like I like a melody. I'm sorry. I do like a bit of noise as well. What am I talking about? I lived in Berlin for 2.5 years. You can't live in Berlin 2.5 years without enjoying a bit of noise. But I don't plug in the Cracklebox because it doesn't sound very nice. It just goes. You're too young to know, but that's what dial-up internet sounded like as well. Do I have any other questions? Yes.
Have flexible screens been on your radar at all?
I have seen some awesome flexible screens. I have not personally used any flexible screens. I don't tend to, it's not like a judgment, but I don't tend to do like screen stuff or LED stuff. It's just not my, like I tend to do like haptics, like motors or sound primarily. I'm not averse to an LED, but it's not my area of expertise, and ditto with screens. I have seen some really cool stuff coming out of Shenzhen though, in particular. There's some crazy stuff in the markets, these flexible things. I actually saw someone who made it like a flag, like a screen kind of thing. That was really cool. But yeah, I've not personally got any juicy things to share there. Sorry. Anyone else? Hello.
Hello. Same thing with him asking about screens. I missed the beginning of your talk, but does embroidering like solar panels come into You've done like
Funny you
backpacks,
should
jackets,
ask that,
jackets.
because I do actually have a good thing to share. I haven't personally embroidered solar panels, but there's Dr. Kitty Young, Yeung. I think her handle is Art by Physicist. Anyway, she did like a Kickstarter last year for a couple. She works at Microsoft doing quantum physics, but like has a hobby that I know, disgusting, right? Like she's a quantum physicist and her hobby is also sewing solar panels. Ugh. So she worked with this awesome company in Germany she made these. Can I bring it up here? Is that possible? Oh no, I'm not going to show you. But if you look her up, she made these like dresses, and these giant bows on the shoulder were actually made out of a flexible solar panel. So, and that's the first time she's the first person I've seen bring something to market like that. So that technology exists. You can buy it. I did ask Kitty, I was like, how did you, like, is there somewhere you can go? And she's like, I had to speak to so many different German people to get this made. Like, she lives in Germany now. But she was like, yeah, it was not easy, but it is possible, which means if it's possible, and someone's figured it out, then eventually someone will make it easier. But yes, it exists. It is coming soon, but look her up. Definitely look at that one. Yeah. Next, anyone? Oh, there's a person there. POV. Oh, POV is persistence of vision, not point of view. Which is sometimes, persistence of vision. It's like when you've seen those projects when you like move stuff across and it makes that, like you can have a clock, right? That's just on a flexi. I'm not explaining this very well at all. Oh my God. I drove for like 7 hours yesterday. I'm very tired. Anyway, I have not done anything with POV personally. It would be very easy to do something with POV. I think it would be very cool to do something with POV. Like, for example, sails. That would be really cool. Or a giant windmill. I think that'd be awesome. I've not personally seen any wearable POV stuff. You'd have to like move quite quickly. That's a very good, would that go fast enough? Is that fast enough? I don't know. I don't know how, no, I've not done it, but I look forward to your findings next year. Oh, one at the back, yes.
To continue to nerd out about embroidery, electronics.
Oh, I totally forgot to tell you I've got a workshop on Saturday. I'm doing a workshop on Saturday. I made up the kits earlier. Big shout out to Taj and Alvaro who helped me wind a lot of bobbins. Thank you. So we've got 40 kits. I've made up 40 kits, and basically it's very much a simple introduction to sewing circuits. Some of the, like how to work with thread. Let me see, have we got a picture of one of the things we make? We're going to make one of... No! This one! We're going to make this. We're going to make a sparkle heart emoji, but light up. It's plushy. We're going to basically just make a simple circuit is what we're going to do. So that's on Saturday at a time. What? 2:00. That's on Saturday at 2:00. I don't know what the deal is with workshops here, to be perfectly honest with you. Do you just turn up? Is that what happens? All right. Yeah, hardware. I will be there. I'll definitely be there. I guess it's first come, first served. And also I'm just going to be hanging around generally. I'm going to be drinking chunk later. There is for those of you who don't know, there's a chunk meetup later. Which chunk is a hacker cocktail. It's basically Club Mate, rum, and lime, and it's TCH. Don't you shake your head at me, sir. In the social area, not in this bit, the other bit. Shady Tell. Thank you. Yes, the place where they've got the throne of Mate. Yeah, so Shady Tell. So I'll be there later, and I'll be at Whiskey Leaks, no doubt. It's a small conference, so just grab me. I'll be hanging out. And also, I will probably, in a second, put my microphone down and go outside, and we can see what of my projects that I've stuffed in this bag, see if any of them actually work. So I might seed this. If anyone's got any burning questions they want to ask in a public forum, please ask now, or elsewise I will be going outside just to the left, to the nearest sunbeam on the left. You'll find me. Right, that's it. Yeah? All right. Woo! Thank you.
All right, thank you so much. Just a couple announcements. Whoa. You can dial 4 NFT for tacos. If you're interested in, not anymore. Maybe not anymore. I believe there are still lots of reservations left at the Doe Bay Cafe restaurant for dinner. If you're interested in grabbing some dinner over there, for NFT, yeah, for tacos. There's also some soup at the back of the dome here. If you have any sort of vessel to pour soup, which is codename for beer, into, there are 3 different types of soup back there. And we have music starting in a minute, so load up on some soup and kind of have a music-filled happy hour. Make sure to stay hydrated with soup and slather on your sunscreen. And then if you got a dog, pick up the poop. Lost and Found over at Reg. And we're going to have music starting here in probably about 10 minutes or so, however long it takes to set up. So we'll see you here in a minute. Hello. So I was just informed that if you're interested in getting dinner at the cafe, they are accepting walk-ups right now. So you can just walk over, and they will seat you fairly quickly.
Whoever